Welcome to the Industrial IoT Spotlight, your number one spot for insight from industrial IoT thought leaders who are transforming businesses today. With your host, Eric Walenza.
Welcome back to the Industrial IoT Spotlight podcast. I'm your host, Eric Walenza, CEO of IoT ONE, the consultancy that helps companies create value from data to accelerate growth. And our guest today is Gianluca Redolfi, Chief Commercial Officer of Sateliot. Sateliot is a satellite telecommunications operator that provides global and continuous NB-IoT connectivity to companies that make up the IoT universe. In this talk, we discuss the paradigm shift that is being enabled by a rapid reduction in satellite launch costs and the extension of the terrestrial NB-IoT protocol to space. And we also explored the early adopter use cases for satellite connectivity, including both primary connection and as a roaming service. If you find these conversations valuable, please leave us a comment and a 5-star review. And if you'd like to share your company's story or recommend a speaker, you can email us at team@iotone.com. Finally, if you have an IoT research, strategy, or training initiative that you'd like to discuss, you can email me directly at erik.walenza@iotone.com. Thank you. Gianluca, thank you so much for joining us today.
Hello, that's a pleasure to be here. Thanks for inviting me.
Okay, so this is a really interesting topic because I think it's quite on the cutting edge of telecommunications, this topic of satellite NB-IoT. But I think for you, it's a topic that you've been bouncing around in for quite a while. If I look at your CV, I can see that it looks like your first touch point here was maybe even when you were still in university, if I'm right, back in the 1990s when you set up basically a software company and ended up selling it off. Is that right, that you were basically a university student and then successfully selling off your first company?
Oh, wow. That's, back in the days. I started the company just after university and it was quite successful, yes. But then maybe I can mention that I've been doing a few other startups in the early 2000s and moved to management consulting. Quite nice. I've been living for those reasons in 9 countries in my life, mainly working on telecommunication mobile operators. Now, actually, I'm spending my time between Barcelona and San Diego, and it's very exciting times with Sateliot. I'm going to tell you more about Sateliot later on. That's a revolution. Satellite communication is a revolution.
Yeah, well, I tell you, choose the right cities, Barcelona and San Diego. It's a good places to be spending your time. It's interesting because it looks like this first company that you set up was also in track and trace for terrestrial shipping, right? So I imagine it was a completely different tech stack back then than to what you're building today. But so tell us, you're now the chief business officer with Sateliot. I guess the company was founded about 2 years before you joined. What was it around the company that made you feel this is the next challenge that you want to take on professionally?
Actually, the story of Sateliot is a great idea. Founders have been setting it up. It takes some time to get to a certain level, to have more people joining. I know, and I've been working with Marco and Jaume and Alberto and Carlos and Jose since some time. So I joined at the right time. Okay, that was probably a little bit more than a year ago. Mainly, my view is that I've been in the telecom sector for basically all my life, or working life at least. There's something special on what's happening on the space, or what is called new space. That's the revolution of allowing very, even small companies having access to something that was just for a few companies before. I found it extremely interesting and powerful, mainly because the telecom industry on Earth is quite saturated. It's quite limited what can be done. Space is still quite open. There are so many things to be done. The main things are happening already now.
Can I ask you, when you say it's saturated, do you mean saturated from a business standpoint or from a bandwidth standpoint?
No, I'm saying from a business standpoint.
Yeah, there's certainly some legacy companies that are hard to move there. if we think about this value proposition, right, of 5G NB-IoT from satellite to Earth, what's the primary value proposition? Like, where is this going to be a superior solution to what the legacy carriers are offering?
There's something special about satellite. Okay, satellites have been around since the 60s. Satellite industry in general has been in the hands of few companies. Probably most of them very, very related or fully owned by the governments. And this was basically because the investments that were required were huge. Just to give an idea, typically to set up a satellite, you could invest probably clearly between 500 million to a billion or more, and maybe it can take 5 to 10 years. Okay, so that's not for everybody. Okay, the change in paradigm is when this is going to cost probably less than 5 million, maybe 1 million, or even less, depends on what you are launching and setting up. And basically, the launches are accessible to basically everybody. Okay, you don't need to have a big funding for it. Of course, you need to have a reason to do it. The big enabler, as we know, has been SpaceX on the launching, and of course, the ecosystem of launches has been set up also around it. Now, something was quite special on satellite on telecommunication compared to what has been happening on Earth. If we go around the globe, we've been seeing a standardization of what are the telecommunications. GSM has been playing a big role along with 3GPP to have basically the same cellular phone now and working everywhere. You could go basically everywhere with the same cell phone. Okay, it was not the case in the 70s, in the 80s, in the 90s. You had specific, much more expensive solutions. Okay, in satellite world, this is just happening. It was completely disconnected on the telecommunication from the terrestrial world and from being standard. Okay, so if you wanted to buy up to now as a communication device, you had to buy this from the same brand, the same protocol of the satellite you want to use. Which again is not the case. You could use your phone and switch operate on your own country or go to another country and it work. Okay, now it's commodity. Everything think it's a reality, but that's not. It was not there before. Okay, actually, if you go back even in the 80s, what happened with the software and the OS, IBM, Compaq, and the way we are seeing now the computer industry and the standardization that you have a software works in all the computer, it's another example of the power of standards. So what we are doing, we have been part of the 3GPP, which is the organization that sets the standards around the globe, working, actually leading from the space side to have a new way of doing communication from satellite. And this is a standard. So the 5G standard that is now working on terrestrial has been extended for the first time in history to satellite. This means that the same device, unmodified device in hardware, can connect without any change, no bigger antennas, to a cellular tower on Earth or to a satellite, depending where the coverage, which coverage is better. Okay, so that's the key change in the full ecosystem of communication in satellites. Sateliot specifically has been working on narrowband IoT, which is the specific focus that we have. And this is a huge change because you probably heard about it, but the communications, cellular communication are just covering about 10% of the world, 10, 12%. So the rest, almost 90% of the world, doesn't have any type of coverage. That's a big gap. It's not a big gap when a human, because the cellulars are set up even by licensing where the humans are. But if you are a thing and you want to be connected, you might have a big gap. And this is exactly what we are feeling in with our satellite communication and the standard. We're not the first one. There are other companies that are doing it, not on standard, so you need to buy much more expensive equipments, probably pay also quite expensive communications rate every month. So we're looking into enabling the massive adoption of IoT in the world. The levers we are seeing that are generating these massive adoptions are basically based on price, because if you pay too much, well, you just use it in a very small part of your activities. Okay, and the key points are the device you need to buy and the price of the connectivity. The devices, the more standard they are, the less expensive they are. If you can buy now a phone and everybody has a phone, it's because it's the same phone everywhere. If every country would have a different type of communication, the price of phone would be much, much higher and the penetration of phone would be much lower. So we're talking about that a standard narrowband IoT 5G probably now is around few dollars. Proprietary solutions are probably much more than $100. That's the key proposition and the key differentiation we are offering to the market.
Okay, interesting. So you have these four things that are happening. You have 500x or multiple 100x reduction in the cost of satellites, and then also probably a 10x or something cost in the cost of delivering the satellite to space. Then you have the standardization of the protocol so that you don't have to use custom hardware, and you also have the declining cost of that standard hardware. So all together, you start having cost structures that actually make sense for building applications on.
The first thing that we are seeing is that there's an unstoppable willingness of measuring everything in the world. Okay, it happened on us with smartwatches and widgets, gadgets around us. Okay, we want to measure everything, and then it went into the cities, and now it's getting out of the city and basically where we would not expect maybe 15 or 20 years ago. And this is happening basically in all the industries, because when you start measuring, you start optimizing. So the key use cases that are out of coverage most of the time are the ones, of course, that are trucking, shipping, maritime. I can tell you agriculture. I can tell you cattle management. I can talk about fisheries, forestry. I can talk about oil and gas pipelines. I can talk about a lot of applications that are not necessarily on coverage. Partially, yes, but they are now struggling to expand this measurement and this productivity out of the coverage. So basically, this is getting into all the industries, all the applications that we have around us.
And then within these applications, who would be your customers and who would be maybe your channel partners? So are you going direct to the application developers? Are you working with the MNOs? How do you work within that ecosystem?
Let's go back one moment. So what we are setting up is a constellation of satellites that are not geostationary, are low Earth orbit. It means that basically each satellite is spinning around the globe every about 90 minutes at probably 24,000 kilometers per hour, so quite fast. So you basically have with few satellites coverage everywhere on the outdoor, everywhere on the Earth, on the planet.
Sorry, can I ask one question? Just because I'm just personally curious. So how does coverage work? Like, how many satellites would you need? And then do you basically have coverage only when the satellite is, I guess, within a certain kind of radius overhead, and then maybe you go in and out of coverage, but it's within a close enough period that you can just wait to send the next data package for 15 minutes until the next satellite comes in range? How does that constellation actually work to provide the right level of coverage?
Yeah, that's a great question, and very happy to answer because it's not necessarily easy to visualize it. So, with few satellites that we are going to have and be able to give the first service by next year, it's a big step because next year the world is going to have the first standard-based satellite connectivity for narrowband IoT. You're basically capable of sending and receiving between 4 to 6 times per day messages everywhere in the world. We are going to launch up to 256 satellites in the next 2 years, and this will give almost real-time connectivity. So you're going to see a satellite basically every other minute. And there's, of course, a ramp up in the middle of this of the two numbers I just mentioned. Satellites are quite close to Earth, below 600 kilometers, which is quite low compared to a geostationary that is at 37,000 kilometers. Okay, so quite close to Earth, and this allows quick and communications and being less sensitive to anything that could happen between the device and the satellite.
Gotcha. Okay, so in year one or two of operations, you're going to be dealing with use cases where maybe a fishery needs to send the temperature of water every a few times a day, and that's sufficient for kind of a monitoring activity. And then after you have these 200 plus satellites and you have more real time, then you're going to be able to do a kind of a wider range of maybe machine monitoring, or so I guess your use cases will kind of evolve as the network develops.
Yeah, exactly. Actually, we launched something that we call the Early Adopter Program, EAP. We've been seeing a lot of attention from basically all the different use cases. I would say that even the ones that they ideally they require much more connections per day than what I mentioned are there because they know that retroactively their investment are conserved, are good because as our constellation will grow, they will still have these messages just increasing. Any investment is not lost. Of course, the biggest take up on the ones that they are good enough with few connections per day.
Then a question around, I guess there's use cases if you're tracking a shipping container, for example. That container, it might be at times it's in port or it's on a truck and it has access to a terrestrial network, and then it goes on the sea and it loses access to that network. Is the intention to have kind of 100% on your network for these devices, or is it that sometimes they'll switch on to a legacy network that might be lower cost, and then when it loses connection to that, it switches to yours? Or how do you imagine that dynamic working?
By definition, all these devices they are dual mode, okay, because the same device can connect to terrestrial and to satellite. This allows basically with the same SIM card that you have on your device that you can connect to the best network you have. Of course, if you have a terrestrial network, you have constant connectivity, a very, very affordable rate. The best solution is to use terrestrial. And whenever the device is out of coverage of the terrestrial cellular network, automatically connects to Sateliot and to our satellite constellation. Okay, that's quite a revolution. Eh? Can you imagine that whenever you are out of coverage, and then it's very, very inexpensive. So it can be applicable to a pet tracker, to a bike, to a car out of coverage and an emergency situation. It can be a very, very, very interesting, even for our own life, not just for things. So what I was saying before is that since the coverage by definition is planetary everywhere, we are also going to sell it everywhere because we need to sell everywhere. The best position to be in the market are the telecom operators. So we are signing a lot of agreements, roaming agreements with telecom operators. From a telecom operator point of view, it's quite easy because they see us like a roaming partner, so they don't need to invest anything, and they have all their customer, extending their coverage to everywhere in the world.
Yeah, that's a strong proposition, right? Because it's, I guess from the end customer as well, there's no particular downside. If if you're within the terrestrial network, you use that and your cost structure remains the same. And if you leave, then all of a sudden you have a roaming option where before you didn't have connectivity, right? So that's a great proposition. What does the cost structure look like? I mean, I guess this is going to be evolving as this technology is, developing quite quickly. But if we look over the first couple of years, what would be the ratio between kind of a terrestrial network and satellites network?
Well, probably in the short term, satellite will always be a little bit more expensive, okay, than terrestrial for many reasons, but basically because it's more expensive to set up. What we call a cell tower from space, which are our satellites, okay. So it will always be better to connect to cellular terrestrial network if you have it, okay, if you have access to it. The mix will be depends a lot on the use cases. A lot on the use cases. Some use cases will be more on terrestrial. Some others will be basically all the time in out of coverage. I mean, if you think about maybe fisheries and marine buoys and so on, maritime buoys, they're going to be most of the time out of coverage. So we are enabling new solution that would not be there otherwise. Actually, we've seen few of them popping up, but not getting the right traction because the connectivity is an issue still.
Yeah, and I guess it depends on how much data they have to send as well, right? So it's quite a different thing if you're sending the temperature of a sensor, once every 3 hours, or if you're, you're certainly not going to be streaming video on these anytime soon. What are the kind of the ranges for bandwidth and for just a volume of data that you expect the initial use cases to be looking within?
Narrowband IoT is not done to stream video. It's done to send very small messages, okay, comparable to an SMS or that basically are more than enough to transmit the key information that you have. And basically, in a few bytes, you can send a lot of information that is relevant. Most of the sensors, they can be very more basic or more complex from just one dimension, measuring temperature or what else, or they can have more. But this is enough the capacity to retrieve, is to send our communications bidirectional, the key informations. What are the key information? Typically are you have, as you said, temperature, humidity, moisture, wind speed, mechanical percussions. You can have door open, door closed. You can have different status. You can have visibility. Okay, we have cases where sand storms are limiting the visibility on highways in the US, and you want to have a constant check of the situation along the highway. You can have bees and hives to be controlled. There are so many different applications that we are every day surprised about the what we're seeing that can be done with the IoT.
So I understand you're sending your own satellites. Again, I'm just kind of educating myself as as we continue this conversation. But I guess one question I had was, would it be possible for you to also use existing satellites, maybe have partnerships with them, or is it that you are the first ones that are basically launching this infrastructure into space? It currently doesn't exist on other satellites. Can you just share a little bit about the actual hardware that's on the satellites, and then do you envision a point in the future where you might be collaborating with other satellite operators and combining data sets or combining coverage in some way, or do you imagine this being quite separated also into the future?
In the short term, for sure, it's going to be our own constellation, our own building, our own solution in our own satellites. That's basically because you're having the control of it, and you can make it the best out of it, and you can make it also the most optimal configuration. Nevertheless, I don't really, I cannot say that in the future that might be becoming a commodity, and then basically what we are doing could be done on a constellation that is not our constellation, or we can use another constellation. Okay, this is not the case now. It's not the case now.
Okay, yeah, I guess this is going to be an interesting question to see how the space industry develops here. I guess we took it for granted that you're working with NB-IoT, but would there be other options to provide a similar level of service from space, from a satellite, and you prioritized NB-IoT, or is that really the only? So, I guess there's legacy options which are quite expensive, but why did you choose this this protocol in particular?
Well, there are different. Of course, there are different way of approaching the market and thinking about what a company wants to do. The key typical successful strategies are to be very focused and the best on a certain niche, and being sure enough that the market will be big enough for the opportunity. We see in narrowband IoT, a lot of companies are focused on broadband. We know it. They are much more famous. They're giving broadband everywhere in the world and so on. We always thought that narrowband has been the solution for the IoT, and has been extremely limited in coverage, and extremely limited in roaming option if you want to move from one place to another. So a lot of let's pain points. Yet at the same time, you don't want to change what you are focusing, because you could be tempted by doing many other things. Now we are focused on narrowband IoT. It's going to be for the wire. It doesn't mean that, there are other opportunities that can arise in the future, but that's what we want to do, and there's still a huge market to be served.
Yeah, no, I see that as well. That a lot of the, there's also terrestrial networks that are trying to move into rural areas, but in the end, they require a lot of on-the-ground infrastructure, and it just makes it very difficult to have kind of reasonable coverage. So I think placing, especially just because the data volumes are relatively small, placing this infrastructure in space actually this makes a lot of intuitive sense. Are there any other, aside, obviously there's cost and coverage, and those are kind of maybe the key parameters. Are there any other differences in space? If you look at security, are there benefits or challenges, or is it exactly the same? Any other factors that would make a company either want to or not want to work with, as you say, a station in space as opposed to some option on land?
I would say that probably we are on the IoT satellite service. We are the most secured one, not because we're doing something that is necessarily unique, but just because we are using the same encryption and protection you have if you use a SIM card from a telecom operator now on terrestrial. So since it's the same protocol, it allows to have the same type of security. If you use proprietary solutions, might or not be the case. If I'm using now a narrowband IoT device with one of the telecom operators, you basically maintain the same type of security. That's a big plus. The people maybe are thinking that it's not that relevant, but it's exactly the same. Okay, so it's a same protocol. It's like a cellular GSM protocol. Nobody can see.
Yeah, no, I think for corporates, standardization is key, right? I mean, risk minimization is, it's always going to be a big question when it comes to new technology. Just if we look more broadly at the environment in space, it sounds like it's starting to fill up a little bit, especially because SpaceX has this kind of volume strategy of, it's like conquering territory. If you look forward, maybe 10 years into the future, do you see any challenges just in maintaining kind of, I guess not service levels, but just maintaining the environment of space, free from debris, issues with satellite collisions? This is maybe looking beyond the scope of just your business, but how do you see the environment, and especially kind of international collaboration around maintaining that environment developing now?
It's a very nice question. So, question. Actually, I've been on this small sat conference in Mountain View a few months ago, and there was a big discussion around it. Okay, and the space debris are a key thing. Now it's not relevant. In 10 years it will be. So many things have to happen to maintain a certain level of security in the space. Our satellites, especially for the big ones, okay, our satellites are quite small. They are relatively in a, let's say, secured and good orbit, so they are not affected that much about it. Okay, but in general, if we speak in general as a space consideration, yes, debris are an issue, especially because they never stop. If you have a collision, it's not that you have one collision. All these small debris that they go in all directions, they continue flying forever, and they can go and against another satellite, and then it can go ahead at infinitum. So there are also companies that are setting up a kind of cleaning of debris in space. The big debris are tracked, like there will be satellites. So there is a kind of monitoring of what's happening. We need to think, if we think about an ocean and boats around the ocean, which is just 2 dimensions, still the ocean is very big compared to the boats that are going around. If we think about, and they're quite big, the boats. If you think about space, it's 3 dimensions. And most of the satellites are quite smaller than boats. Okay, so we still have a lot free space to move, but of course it has to be monitored.
Yeah, no, I was just thinking about the ocean example, and that we have not done a very good job as an international community of keeping the oceans clean, of debris and so forth. But fortunately, yeah, it's an easier operating environment to some extent, right? You can see things coming and you can move out of the way. Whereas when you're moving at 90,000 kilometers an hour, then plan ahead. Yeah. Okay. No, that it would be really interesting to see how this evolves, because I guess there's all sorts of tragedy of the commons challenges there with who pays the companies that are cleaning up the debris, right? This is an issue where I guess the governments will have to figure out. Maybe the United Nations, somebody will have to figure out how to finance that. Great. So I know that you're pre-revenue now, but I imagine you're already starting conversations with customers since you're setting up next year or beginning operations next year. When you look at the first use cases that you expect to scale, what do you see as the big ones on the horizon?
There are mainly, I would say, three that are the most delay tolerant ones. A lot in maritime, okay, maritime and container tracking, not just maritime actually, because it's not easy if you move around the world. It's not easy to have roaming and connectivity, even in terrestrial with narrowband IoT. So we are solving not just the no coverage, but also the seamless connectivity, enabling being connected in different countries. Then we have a lot of cattle management, wildlife, conservation companies, agriculture a lot, especially big countries where it's not enough. Brazil is a big country, and we have many countries, but Brazil is quite huge in demand, especially because the coverage. I mean, it's very large country, and the coverage is not a lot. Probably we are talking about 23% of coverage of all the agriculture. Okay, so again, what I said is I would say everybody can go and get into our website. There's an application form if you want to know more, and if you want to be part of the early adopter program. We are constantly doing it. They can have test lines for free. Yeah, they can start integrating, using, seeing, and then liking it.
Most of the early adopters, are they operators, or you have equipment, kind of operations companies or application developers you have going and working with you directly? How does that work if they wanted to collaborate with you directly?
Yeah, actually, that's a good question. We have both of them. Okay, we have operators, and we have a lot of final service providers that they want to see how it works with their devices, and basically, it's a mix. It's a mix. And interesting, we have a lot of applications, a lot.
Yeah. Okay. This is going to be very interesting. I'd love to have a follow-up in maybe 18 months or so, once you have the the next batch in space.
We're going to invite you at launch, okay, or the day after launching. So you're going to see how it is.
Yeah, I saw on your website the next launch is it's like 112 days into the future or something is I think the next one due, right?
Actually, we're launching with SpaceX, and it's going to happen on the 1st of January 2023. I think it used to be in December and been moved by the launcher to the 1st of January 2023. Now launching is becoming quite a commodity, and it's very good because it's not just is a challenge to have your own technology, to of course to make sure that everything works, but also it will be a challenge to launch and maintain on the space the satellites, and it's less an issue. It's more and more a commodity. Few very nice companies, very professional and very good in launching. So basically, you have launching opportunities quite often.
Yeah, this has been really really transformative, right? It used to be, I guess, quite an endeavor to get space on one of these shipments, and then if it gets delayed, then you're waiting 6 months or something for the next opportunity. And now it's like hopping on a bus to some extent, right? You can just wait for the next one to come. And because we have also people from the investment community listening on the podcast, I'm curious. This seems like the type of company where you need to have a fair amount of investment to go operational, even though the cost has come down so much. Do you have any investment rounds planned on the horizon?
Good question. So we closed our Series A for 10 million euros December last year, and we are opening actually now the Series B. So that's a very good moment. If there's any investment firm that is interested, we are very happy to explain what we're doing, to get into the details, and to show the big opportunity we have in front of us.
Okay, great. So if somebody wanted to get in touch with you, either to discuss investment or to discuss becoming a customer, I guess on the customer side you have an application online, so we can share the link to that in the show notes. For other conversations, is it best to find contact information online, or what's the best way to reach out to the team?
There are many ways. Okay, so of course, if somebody goes to Sateliot, which is satellite and IoT together, Sateliot.space, which is our website. They have many ways: contact, info. There's an investor relations page, and they cannot miss it. They can also write to me, Gianluca.Redolfi@Sateliot.space. Okay, so my name dot my family name at Sateliot.space. That's quite easy. Or they can find me on LinkedIn. I mean, that's quite easy.
Great, Gianluca. Anything else that you wanted to touch on today?
I think it has been very nice to talk to you. Always nice to explain what we are doing, and that's a big opportunity for us to share how the world is going to be. There are so many companies that are not just us that are doing transformative approaches to the world. That is always nice to listen and also to explain what you're doing. The world in 3 to 5 years will be much different, hopefully better. We think that's our lemma: a connected world is a better world, and that's what we're doing. So thanks a lot.
Well, thanks for coming on. Really appreciate the time.
Thanks, Eric. Thanks to everybody to listen.
Thanks for tuning into another edition of the IoT Spotlight podcast. If you find these conversations valuable, please leave us a comment and a 5-star review. And if you'd like to share your company's story or recommend a speaker, please email us at team@iotone.com. Finally, if you have an IoT research, strategy, or training initiative that you would like to discuss, you can email me directly at erik.walenza@iotone.com. Thank you.